Hi, in this video I will build a DC motor control circuit. This circuit can control the motor speed and direction of rotation. This circuit divided into two main parts. Power circuit, which consists of DC supply input terminal, two relays, MOSFET plus freewheeling diode and the motor terminals. The control part consists of microcontroller connection and I will start first with the power circuit, connector, con BTR 500. I will use two, one for the DC supply and the other for the motor terminal. Relay. The relay I have called G5L. Then the power MOSFET is named IRF740 and the diode. This one will be fine. We'll save this work now. Save. I put it in a suitable place. I'll call it DC motor control. Before doing any wiring, sometimes you select a wrong sizing or a wrong component. So I used to do a very nice trick. I move from schematic to board and I print this component on a piece of paper and I make sure that these components will fit the one I already have. For example, the relays has different shape or different dimension, so if the relay I have will not fit, I had to go through the Eagle library until I found the one will fit the one already I have. Switch to schematic to draw our connection. First we need to name the terminals. This is the DC input. This is the motor terminal. Okay. Now I don't need the relays coils here, so I will move it down. Put those two a little bit close to each other. Okay. This is a 12-volt DC supply. I connect the two normally close together and the two normally open together. Delete the extra. I will rename this wire 12 volt. I will rename it to 12 volts. Name 12 volt. Now I will connect the MOSFET. And the MOSFET will connect it to the ground. Finally, the diode will be connected between the two normally open and normally closed terminals. So one pin here and the other here. Motor terminal. Now we finish the schematic diagram of the power circuit. I will save my work and I will move to board. First, I place the component in a suitable place. I will use the move tool. So the DC input. Now the motor terminal. K1. I will place K1 here. K2. MOSFET. Finally, the diode. This is good place. Now I will use the auto route tool to route the tracks, but before I need to control the wire size, track size, so I will use the DCR. Clearance, it will be 0.6 millimeter, and I will do the same for everything. And from size, I will choose 1.5 millimeter. Apply and cancel, and then I'll use auto router. It's no top layer, it's only button, and continue. Start. End job. Now I finish the power circuit tracks, which is good. Let's go to the control circuit. I will move back to the schematic. First, I will add the microcontroller connection or terminals. Phonics MTP4. So I have 4 pins, one for the PWM, 2 for the relays, and the ground. I will start first by the MOSFET gate drive. So I need 4N25. You couldn't find it, so I'll write just add 2 stars to have more specific search. That's it, and I will use this one. And I will need some resistances for this circuit from RCL, REU. This one is good, looks size good. Okay. So first I have a resistance from here to there to turn on the LED, the optocoupler LED, and this is the ground. Give it name, ground. Yes, connected. And the value of this resistance is 220 ohm, 220. I'll connect this terminal to the 12 voltage supply. 12 volt. Yes. And also I have some more resistances. Copy. Resistance and the gate resistance. And gate to ground resistance or support tower resistance. We just need to define the value of each. The first one is 470 ohm, this one 47 ohm, and the last one is 10 kilo. Now I just need to connect. Good. Now we finish the MOSFET gate drive circuit. We need to add the buffer circuit. So from add, the buffer I will use is called ULN2303. Okay, well, I write 2 stars. Okay, here's it. This one is nice. First relay, second relay. This pin will connect it to the ground, this to the gate, and this is relay to activation signal, relay to. Those 2 contacts are connected to the 12 voltage supply. Also, this pin, the diode common, will connect it to the 12 voltage. Now here's the buffer and the gate drive. We need to add it into the schematic onto the board. I will use the move tool. The microcontroller connection, optocoupler, gate resistance, the pull down resistance, the gate resistance, the MOSFET gate to ground resistance. Finally, the ULN, I will place it here. Now, the control wires will be less thickness than the power circuit. So from DCR size, I will reduce it to 0.6 millimeter, and I will use the auto router to finish the job for me. Start. Enjoy. As you can see, the auto router failed to find a suitable path for this trace, so we can make it by ourselves. I just simply move this one little bit like that, wider, and this place wider, and I will use the route tool, bottom layer. I can do it myself. Now I finished, I solved the problem by myself. Zoom. Now we need to add the copper filling. I will select the polygonal, make sure that's 0.6, and I will draw, just make my angle 90 degrees. I'll call it ground. Brightness, I will use the brightness. Good. Finally, I just need to the border, make it a little bit closer to my circuit, and also this one is too wide. Brightness, and I modify the border with my PCB size. Now let's generate the Gerber from CAM processor. Gerber, make sure that's Gerber 274X processor. Okay, now you can send the Gerber generated to the PCB factory and you'll get your PCB. Thank you and bye bye.